Hello everyone. In today's lecture, we'll solve two more important problems on the complex number. The first problem is they've given a complex number v. If v, they've given z square plus z plus 1 divided by z square minus z plus 1 is a purely real complex. The purely real complex. Then they're asking to find the modulus of my complex number. So if it is a purely real complex number, so we know that in a purely real complex number, the complex number will be equal to conjugate of the complex number. This is the property of purely real complex number because the imaginary part is 0, right? So the z and z conjugate will be same. If z is purely real complex number. Okay. Now next, they've given that v is a purely real complex number, right? If v is a purely real complex number, so v will satisfy this property. So v will be equal to conjugate of what is v? V they've given in question as z square plus z plus 1 divided by z square minus z plus 1 is equals to conjugate. Conjugate of this v will be z conjugate whole square plus z conjugate plus 1 divided by z conjugate square minus z conjugate plus 1. Okay. Now cross multiply. After cross multiplication, we will get z square plus z plus 1 multiplied by z conjugate square minus z conjugate plus 1 is equals to z square minus z plus 1 multiplied by z conjugate square plus z conjugate plus 1. Got it? Now copy this one. Now we'll multiply this and we are going to simplify this. Next page. This we got right. Now multiply, open this brackets. We will open the bracket, we'll get z square multiplied by z conjugate square plus minus z square multiplied by z conjugate. Got it? Next, we'll get z square plus z into z conjugate square minus z into z conjugate plus z. Again, plus z conjugate square minus z conjugate. Got it? And next is equals to right hand side, we'll open the bracket. We'll get z square multiplied by z conjugate square plus z square multiplied by z conjugate plus z square. Now minus z of z conjugate square plus minus z of z conjugate minus z. Next plus z conjugate square plus z conjugate plus. Got it. I think now look carefully, anything is getting cancelled. It will see z square multiplied by z conjugate square, z square multiplied by z conjugate square will get cancelled. Minus z square multiplied by z conjugate, and here plus z square by z conjugate. It will come, this will not get cancelled. Now z square plus z square plus z square will get cancelled. Z multiplied by z conjugate square, this also will not get cancelled. Minus z into z conjugate minus z into z conjugate will get cancelled. This z will not get cancelled, and this z conjugate square and z conjugate square will get cancelled. This z conjugate will not get cancelled. Plus 1, this plus 1 will get cancelled. Finally, we'll bring everything to one side. So here we'll get this one is remaining, everything sent to right hand side. So here we'll get 0 is equals to z square multiplied by z conjugate multiplied by 2 plus 2 times sorry, minus 2 times z into z conjugate square plus z will come to that side. Here we'll get minus 2z and plus 2z conjugate. Next, we'll take 2 common, right? We'll take 2 common. So here we'll get, uh, we'll take 2 common and we'll send to that side. So here we'll get 0 is equals to z square multiplied by z conjugate minus z multiplied by z conjugate square minus z plus z conjugate. From the first two terms, can I take z into z conjugate common? From first two terms, I'll take z multiplied by z conjugate common. So here I'll get z minus z bar. Here also I'll take minus common. So here I'll get z minus equals to 0. Now next z minus z conjugate I can take common. So z minus z conjugate I'll take common. Here I'll get z into z conjugate minus 1 is equals to 0. Now if the first bracket is 2, it means z will be equal to z bar or z into z bar minus 1 is equals to 0. We have seen in the property of complex numbers, especially modulus of complex number, that z multiplied by z conjugate is nothing but modulus of z square. Got it? So here z into z conjugate is modulus of z square minus 1 is equals to 0. So modulus of z square will be equal to 1, and from here modulus of z is equals to 1. Will not take minus 1 because as I said, modulus is always positive. From here we got modulus of z is equals to 1, and from here we got z is equals to modulus of. Now we'll see the question what they're asking. They're asking modulus of z value, right? And they mentioned that z is not a purely real number. Z is not a purely real number. B is a purely real number. Got it? If z is not a purely real number, that means this is not possible. In this case, we have to reject. Z is equals to z bar means z is a purely real complex number, which is not there as they given in question. So here we'll use the second possibility. Z square is equals to 1. Mod z is equals to 1 only. Understood? Here minus sign will not take as modulus can't be. So our answer is 1. Got it? Our next question we'll see. Next question they have given. ABC is a complex number such that modulus of A is 3, modulus of B is 4, modulus of C is 5, and modulus of 3A plus 4B plus 5C is equals to 6. See, whenever in the question they have given modulus of Z square in any form, this we can write as Z into conjugate of Z. This is a very important property used in the previous example also, previous question also. In this question, we'll solve. They have given modulus of A is 3, modulus of B is 4, modulus of C is 5. Got it? So what we'll do here in this expression, which they are saying to find, I'll take ABC common. Take common. Take common ABC. ABC term I'll take common. So what I'll get here? I'll get ABC modulus of ABC, and inside this I'll get 27 by A plus 64 by B plus 125 by. Got it? Now next we'll solve this modulus. I can distribute over product, so I'll distribute. So this one I'll get here modulus of A, modulus of B, modulus of C is E, and here modulus of 27 by A plus 64 by B plus 125 by. Got it? Now we know that they have given, we'll use this property, right? We'll try to use this property. They have given modulus of A is 3. So what is modulus A square? Modulus of A square is nothing but 9. Modulus of A square I can write as complex number A multiplied by modulus of A, which is 9 only. Got it? And from here, can I write that modulus of A, sorry, conjugate of A is equals to 9 upon A. Got it? Similarly, Similarly, we'll solve for b. What is modulus of b? Modulus of b is 4. What is modulus of b square? Is equals to 16. And modulus of b square I can write as z multiplied by z bar, means b multiplied by conjugate of b, which is b bar, is equals to 16. From here, what I can say, b bar is equals to 16 by b. B bar is equals to 16 by b. Next for c also I'll see. For c, if you will see, c they have given modulus of c, they have given 5. What is modulus of c square? This one is 25. Got it. Now modulus of c I can write as c multiplied by conjugate of c is equals to 25. So from here I can also write that conjugate of c is nothing but 25 by c. Now next to solve this problem, I took ABC common, then I distributed mod. Mod A value I know. Mod A value is 3, right? Mod B value is 4. Mod C value is 5. Now, what is 27 by A? We know that 9 by A is equals to conjugate of A. Got it? Can we write this as 9 by A multiplied by 3? This will be 3 into conjugate of A. Now, this one, conjugate of B, 64 by B. So I can write 64 as 16 into 4. This one will be 4 multiplied by conjugate of B. Got it? Next, plus 125 by C. C, we know that the modulus of C is 25 by C. 25 by, this one I can write as 5 into 25 by C. 25 by C, I'll write modulus of C. 5 into modulus. Sorry, 5 into conjugate of C. 5 into conjugate of C. 5 into conjugate of C. Now, next, we know this as 3 into 4 into 5 multiplied by this. Here we'll get 3 4s are 12, 12 5s are 60, right? 3 multiplied by 3a bar, 4b bar, 5c bar. 3a bar, 4b bar, 5c bar. Got it? So, we know that one property, that if modulus of z we find and if conjugate of modulus of z will find, both are exactly same. The modulus value is same, but the magnitude is same for z and z bar. In similar way, in the question they have given the modulus of 3a, 4b, 5c, modulus of 3a, 4b, and a 5c. So this will be equal to 6. Is nothing but equal to, now if it is equals to 6, then the modulus the determinant, the modulus of its determinant in this, so the modulus of its conjugate is also 6. So here I'll get the modulus of 3a bar, 4b bar plus 5c bar is also 6. From here I can write 60 into this value is 6, which is 306. Thank you everyone. Hope you enjoyed. 360 is our answer.